Hello everyone, my name is Hussain and I'm from the Department of ECE and studying in Computer Science and Engineering from North South University. And we're going to be demonstrating our project Future Light right now. And with me, I have my partner Sharia Kobi to help me in assisting this. So first I'm going to be demonstrating the project. So first we come across the homepage. The homepage shows all of the blogs and activities. We will go to sign up and we're going to input our information regarding the sign up, as we put the username, password, name, email, and all sorts of stuff like that. Once we place all of the information, we can click on register and it will going to sign up, and then we can finally sign in using the username and the password that we have created. On entering the sign in, we arrive at the dashboard of the profile, and here we have all the information that we need. If we click on the profile option, we would arrive at this section where we can edit the information containing within our profile. If we click on the chat, we can actually go and talk to the chat bot about various stuffs that includes DNA engine. Like suppose I'm typing an answer, it's going to come up with a response. And the fun fact is we can even delete this chat, or we can even choose to save this chat when required. As you can see that the answers are pretty comprehensive, and we have implemented AI in this case in order to get as many accurate answers as possible. And once we create the delete, as you can see, it gets deleted. Now we are using the two main functions. When we click on the disease recognition, we place a diseased DNA sequence, and using the machine model and the data set, it tries to recognize the pattern and tries to identify the disease that might be included in the program sequence. It has successfully identified the disease, and once it finds out the disease, we can either print it or save it as a PDF. If we save it as a PDF, we're going to be getting a downloaded PDF file which is going to contain the details of the patient, their profile, and also the disease. The second major function of this is the gene reconstruction, where we input the DNA sequence of two patients and they're going to reconstruct a third DNA sequence which will going to be free from the gene disease of the first two sequences. Again, it's running over the dataset model that we have trained using the machine learning algorithms, and it's going to come up with the result anytime now. So you can see that the reconstructed DNA has been provided. This can be used to treat most of the gene disease that we usually see. And again, we can use the save as PDF as always. There is another option for this, is the blog post. When we click on the blogs, we will be seeing the blogs that are made by the registered users within the website. We can even create our own blog. For that, we'll have to go to blog. We'll see that the blogs have been given. We can view the blogs, and we can also create our own blog in this case. So let's try to create one. Selecting an image is mandatory to balance up with the framework of the system. So you'll have to choose a banner under any circumstances. So the post has been added, and as you can see, that is already appearing in the blog threads, and here it is. With the text that I have made, it's now appearing successfully. So now we're going to be signing out and entering the admin panel. The admin panel is pretty much similar to the user panel, except for a certain change that has been made in the profile section. As you can see that the admin panel is more secure than the overall user section. You can see a view all users. When we click on this, we're going to be given the data access to all of the users who have registered in this website. We can choose to edit the information of those users, or we can choose to delete them. Like I'm going to be deleting one of them user right now. As you can see, the user is deleted successfully. The admin has a huge control over this factor, and the admin can also view the blog post that has been made. As always, it's pretty much similar to everything else with the stuff. So that is the basic functionality of the Future Life program.
Hello everyone, I'm Shahryar Kabir from Shabad, Dhaka. I'm currently pursuing computer science and engineering degree from Kannada Vishwavidyalaya. So today I will be walking you through the structure of our project along with an overall code overview, giving the insight into how everything comes together. For the front end, we have utilized the time-lived templating engine to seamlessly integrate dynamic content into our web pages. On the back end, we have built the project using Spring Boot. As for the database, we opted for the MySQL to handle the data storage. To set up this project locally, we need to clone two Git repositories. One for our main Spring Boot application and another for our machine learning model using Python and Flask. Let's open up a terminal window in a new folder, then clone these repositories. As we can see, we have successfully cloned the repositories into our local directories. Now we will fire up our machine learning model first. We will open our machine learning repository in Visual Studio Code. This app.py file is the starting point of our Flask application. Before running the Flask application, we need to run this to Jupyter Notebook to dump three .pki files which we will need later. Open up a terminal as an administrator. And then change directory into the current working directory. Then run a Jupyter server on this directory. Open up these two notebooks. On both notebooks, click on the run and then run all cells. This will generate three new .pki files. Now let's get back to the VS Code and run the app.py file. This will run the Flask application on localhost port 5000. To verify this, we can use a REST API client. As we can see, our 2 API endpoint is working correctly. Before starting the Spring Boot application, we need to start a MySQL server. We will use MySQL Workbench for this task. As we can see, we don't have the required table in our server. To create necessary schema and import data, we will use SQL script from our GitHub repository. Execute the script by clicking this icon. After executing the script, we got necessary schema and data in our server. Now we are ready to start our Spring Boot application. Open any Java IDE of your choice. I am using IntelliJ IDEA. Click Open and open our Spring Boot application repository. The IDE will take a little bit of time to resolve all the dependencies using Maven. After resolving all dependencies and indexing files, our IDE will show our application name beside the Run button. Click on the name and then Edit Configuration. We will get a window to edit our Run configuration. We will configure environment variables from here to safely store our credentials like API and passwords. We can generate Gemini API for free from this website. Now click the Run button to start the application. After a few moments, our Spring Boot application will start running at the localhost port 8080. To check our application, let's open up a browser and enter the address localhost:8080. As we can see, our Spring Boot application is up and running in the local environment. Our project combines two key features: disease recognition using machine learning, gene reconstruction using machine learning. Both of these machine learning models are integrated into our Spring Boot application via REST APIs. The models themselves were developed in Python using popular libraries such as Pandas, NumPy, scikit-learn, and joblib for data processing, model training, and serialization. To serve this model as RESTful API, we utilized Flask framework. For the main application, we use the Thymeleaf templating engine on the front end, providing dynamic server-side rendered views. On the back end, we implemented Spring Boot as the core framework, while MySQL served as our database for efficient data management and storage. To structure the code for this project, we followed MVC design pattern, which plays a crucial role in ensuring the application is well organized and scalable. The model represents the data and business logic, including the integration of machine learning model and database integration. The view is handled by Thymeleaf, which allows us to present data dynamically to user and keep the front end clean and easy to maintain. The controller acts as the intermediary, managing the user input and updating the view or model accordingly. We have deployed our application and machine learning models to production using Microsoft Azure Cloud Service, ensuring high availability, scalability. You can access the live version of our application using the following link or simply scan the QR code provided. Thank you for watching, and we hope you enjoy exploring our project.